Now I come to the lesson 18. Lesson 18. The complex line integral. So we already know the session 17. What is the definitions of an integral? What is the method using the complex integrations? Now we come to the session 18, complex line integral. So what? How to method you are integrating in the complex way? So we suppose if we take plane, xy planes, so we start to count a path. I call this P to Q. I say so divide this path, the line, this path line. So P1, P2, etc., P3, etc. Number of sub interval. I suppose that each point should be a complex number. Suppose I say P of Z1, P of Z2, Z1, Z2 are complex number. Now I say, consider a continuous function. Consider a continuous function f of z of a complex variable z equal to x plus iy, defined at all points of the curve C, extending from P to Q. Extending from P to Q. Divide a curve C into n part by arbitrary taking a point. So if you take this one, so P to Q a continuous function, a complex continuous function. Divide this number of n part, say P1 of Z1, P2 of Z2, P3 of Z3, P3 of Z4, etc. Pk of Zk, Pk of Pk plus 1 of Z of k plus 1, like that. So I say P equal to P of Z0, P1 of Z1, P2 of Z2, etc. Pk of Zk, etc. Pn of Zn is equal to Q on the curve C. Let suppose you take alpha k be any arbitrary point on PQ. Let alpha k be any point on the arc of the curve from pk minus 1 to pk, where we take v delta zk is equal to zk minus zk minus 1. We take a difference, very absolutely difference. We take delta zk is equal to zk minus zk minus 1. So where k equal to 1, 2, 3, etc. If you take very absolute values between the path line, in the path line, so alpha k we define here. So if we take a very negligible distance, means delta zk equal to zk minus zk minus 1, where k is equal to 1, 2, 3, etc. We all know is a continuous path. If we take a summation, limit a summation n run from, as if we take summation and limit n tends to infinity, summation k run from 1 to n, f of alpha k delta zk. So we take where maximum of absolute values of zk, maximum absolute values of zk tends to 0 as n tends to infinity, defined as a complex line integral along a path C, usually denoted by integral of f of z dz along a path C. See, this is the definitions along a line integral of the curve. See, we already familiar the definitions and the properties of a line integral. The same that we applied properties of a complex integrals. See, if you take a integral of p to q, is same as integral of q to p, but sign should be changes. So reverse, if a direction is reverse, if minus c denote the curve transfer from q to p, suddenly integral of minus c f of z dz is equal to minus integral of f of z dz integral c, means integral of minus c f of z dz is equal to minus integral of c f of z dz. So reverse if you take. So second property, integral of c f of z dz is equal to, if we divide this number of curves c1, c2, etc. Say integral of c f of z dz is equal to integral of c1 f of z dz plus integral of c2 f of z dz plus integral of c3 f of z dz, etc. Where c is split into number of parts. Where suppose if we take a curve dividing number of curves, subdividing number of curve, we denote a curve c1, c2, etc. cn. So integral of c f of z dz is same as the integral of c1 f of z dz plus c2 integral of c2 f of z dz, etc. Where c is split into number of parts c1, c2, c3, etc. If a and b are constant, then integral of c a f1 of z plus or minus b f2 of z dz is equal to a integral of c f of f1 of z dz plus or minus b integral of a integral of f of f2 of z dz. See, once again I write integral of c a f1 of z plus or minus b f2 of z dz is equal to a times of integral of c1 f1 of z dz plus or minus b integral of c f2 of z dz. This is the properties of a line integral in form of a complex. See, this is the form a real properties of a real integral. In same property were applied in the complex form, where complex form is a reverse of integration is a negative signs. If a number of subdivided should be is continuous, suddenly we say integral of c f of f of z dz is equal to c1 f of z dz plus c2 f of z dz plus etc. Where c is split to number of parts. Similarly, a and b are constant. We say integral of c a f1 of z plus or minus b f2 of z dz should be equal to a times of integral of c f1 of z dz plus or minus b c integral of c f2 of z dz. This is the properties of a complex integral. If we come to the line integral of a complex valued function, similar same way, if you take f of z is equal to u of xy plus I v of xy. So be a complex valued functions, be a complex valued function defined over a region R, and CB a curve in the region, then integral of c f of z dz is equal to integral of c u plus iv of dx plus I dy. So again I integrated integral of c separating here u dx. So I open this bracket, say integral of c f of z dz is equal to integral of c u plus iv dx plus I dy is equal to, again open this u dx, I separating real part and imaginary part. Here u dx, again I square is minus 1 v dy. Actually this is a v dy, u dx minus v dy plus I times of imaginator integral of c v dx plus u dy. This is the form. First separating, again if you want to integrating, separating real part plus imaginary parts. So this is the way to integrating in line integral or complex in form of a complex. This shows that the evaluation of a line integral of a complex valued function is nothing but the evaluation of line integral of a real valued functions. See, this is the way the given functions you want to separate real and imaginary part, then integrating. So I will take some few examples in form how to method of integrating in a complex form. See, for example, so integral of c z square dz. First, if you take integral of c z square dz, first one along a straight line from z equal to 0 to z equal to 3 plus I. Secondly, along a curve made up of two line segment, one from z equal to 0 to z equal to 3, another from z equal to 3 to z equal to 3 plus I. Now, it's a given problem. Let's make it. You take a curve, so in a xy planes, a straight line passing through origins is a given problems. In a straight line passing through the origin is a form z equal to 0 to z equal to 3 plus I. Z equal to 0 to z equal to 3 plus. Here, all real and imaginary part is starting from origin to straight line 3 plus I. Here, real part starting from origin means x comma y is 0. Again, x is 3 and y is 1. So, is starting again, this xy plane starting from 0 this. This is the graph. So from z varies from 0 to 3 plus I, means x comma y is vary from 0 to 0 and 3 comma 1. The equation made a straight line making equations is given form. So x1 y1 and x2 y2 form. So you make a formula y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1 formula. This is the equation line formula. Y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. That is simplified as substituting y minus 0, x minus 0 is equal to 1 minus 0, 3 minus 0. Suddenly we get this is x1 y1, x2 y2. As substituting formula, y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. Now substituting, so we get y is equal to x by 3. Again, z square formula, again I am simplifying z square. So what's the further z square? We apply the complex number x plus iy whole square. Again I simplify a plus b whole square formula. We get again a plus b whole square formula and separating real and imaginary parts. So suddenly we get x square minus y square plus I times of 2x5. Again, what's the dz is dx plus I dy. Totally as substituting, I come to the problems. So you are also simplifying all the terms. I'm substituting the formula form. Integral of c z square dz is equal to integral of what's x y varies from x. So 0 comma 0 to 3 comma 1. So again, what is the z square? I'm substituting z square is x square minus y square plus I times of 2xy. Again, what's the dz is dx plus I dy. Oh, this is formula. Again, I come to the formula. Integral run from 0 to 0 to 3 comma 1. So x square minus y square dx. Again, I'm simplifying here, separating real and imaginary terms. Dx term. Again, dy terms. I square is minus 1 minus 2xy dy. Again, this is the real parts. Again, as separating imaginary parts, I times of integral run from 0 to 0 to 3 comma 1. Again, 2xy dx plus x square minus y square dy. So is given a complex number. Again, as separating real and imaginary term here. Now I come to the again formulas. So we have y is given a line equations y equal to x by 3. Again simplify, x is equal to 3y. So I convert all imaginary axes to real. So x as substituting x is equal to 3y. Substituting x equal to 3y. Now integral run from you are all x converted to 3y. So integration from y varies. Now again x is equal to 3y. We shall convert this integral into variable y and integrate with respect to y from 0 to 1. So integrate y with respect to 0 to 1. Now again, therefore integral of c z square dz is equal to integral varies from 0 to 1. Y varies from 0 to 1 of substituting x is 3y. So 9y square we get. Y square keep y square as it is into dx a converter. What's the derivative of dx is equal to 3 dy. So substituting here. Again minus 3 x replace x by 3y and y as it is dy plus I times of again y run from 0 to 1. So 2x replace x by 3y. So 3y of y into dx is 3 dy. Again substituting plus so x square should be 9y square minus y square dy. So converting all real part to imaginary term and replace all real to imaginary. So that is we get again and simplifying integral y run from 0 to 1 24y square minus 6y square dy. Simplifying here, multiply 9 times of this, multiply 9 times of minus this times, we get this. So we get again minus 2 times of 3y. Again we get totally we get 24y square minus 6y square dy plus items of y varies from 0 to 1. Again we get 18y square plus 8y square dy. Again 24 minus 6 suddenly 18y square dy plus imaginary term items of y varies from 0 to 1. 18y square plus 8y square suddenly 26y square. Again I am integrating with respect to y. We get 18 times of y square, we are integrating y cube divided by 3, y varies from 0 to 1, plus height times of, again integrating, 26 times of y square, y cube divided by y, 0 to 1. Again simplifying, replace y by 1 and 0, so we get, suddenly we get 18 divided by 3, we get 6, plus height times of, again 1 by 3, similarly you get, again resultant in terms of complex form, 6 plus 26 by 3, 8 times. Suddenly, thus integral of c z square dz is equal to 6 plus 26 by 3i along a given path. Similarly, we come to the one more in form of same, along a path. This is a problems in one form. Again, the segment varies from z equal to 0 and z equal to 3. And then z equal to 3 to z equal to 3 plus I means xy is varies from 0 comma 0 because z equal to 0. X varies from x comma y should be a 0 comma 0. And z equal to 3 means only real term. Imaginary term is 0. X comma y should be equal to 3 comma 0. So means this is, and again z equal to 3 means x plus iy means x is 3, y is 0, means 3 comma 0. Again z equal to 3 plus I means x comma y should be equal to 3 comma 1. So this is the line along a line path. So from now we are splitting this integral along a curve. Integral of c z square dz should be equal to integral of c1 z square dz plus integral of c2 z square dz. So line integral. First, we take along a line C1. So along a line along a x-axis C1. Here in along a line integration x-axis, here y term is 0. So y equal to 0, dy equal to 0. Means x varies from 0 to 3 in the first C1 curve. X varies from 0 to 3. Also, what's z square become? Is x square dx. So z replace x square dx. So first curve is over C1. If you plus along a curve C2, here x varies from 0 to 3, x is 3. So x is 3. Derivative of 3 is 0, means dx is 0. So if we take a curve C2 here, y varies from 0 to 1. Where y varies from 0 to 1. Now z square become, x is 0 because we are integrating along y. So this become, z square become 3 plus I by whole square. So I am substituting in the given problems. Integral of c z square dz should be equal to integral of, in the first curve C1 1 here, integral x varies from 0 to 3 x square dx plus I times of integral of y varies from 0 to 1 3 plus I y whole square dy. So simplify. So directly integrating with respect to x means x cube by 3 plus we get x cube by 3. So integral from 0 to 3 plus I times of, first I open this 3 plus I y whole square, then integrating I times of 9 plus y square we get, integrating simply we get 9y minus y cube by 3 plus 3I y square. So integral run from 0 to 1. This is the form. Again I simplify, replace x by 3 here, y by 1 in the second term. Suddenly we get 9 plus imaginary term should be 9 minus 1 by 3 plus I 3I. So simply we get 9 minus 3 plus I times of 26 by 3. Again we get, simplify, 6 plus 26 by 3I. See, along a fourth, along a curve, result is same. Integral of z square dz is equal to 6 plus 26 by 3I along a given path. So we come to this. This is the line integration and the path integration value should be same. If we come to the evaluated in a second problem, it is same. So integral of minus 2 plus I to 5 plus 3I z cube dz. See, first we make a graph x-axis and y-axis. See, this is away from the origin. So y curve away from the origin, if one unit distance, make a draw. Say this is the line away from the origins. If you away from the path of a integrations, a curve consisting of a straight line AB parallel to real axis. simply say is a line AB is parallel to real axis from a path. So coordinate of a point A is -2, 1. This is the minus coordinate. A coordinate should be -2, 1. And B coordinate is 5, 1, 5. This is along a line path and along a line AB. See, a line AB, suddenly this is an X real axis. Y is along a curve intersector, means this is intercept for Y equal to 1. So along a line AB, Y equal to 1. So derivative of dy should be 0. So X varies from -2 to 5. X varies from -2 to 5. Again, if you come to the straight line BC, you come to the line BC. So line AB is over, you come to the line BC. Parallel to, suddenly BC is a line parallel to imaginary axis. Imaginary axis. So if a coordinate of a point B is now the B of 5, 1, then the coordinate of a point C is 5, 3 is given. 5, 3. So on a line x equal to 3. On a line x equal to 3. Derivative of dx equal to 0. So x equal to 3, dx is 0. Y moving from 1 to 3. So y moving, see BC you observe, y moving from 1 to 3. So that is, if you come to the problem, I am substituting the two. Integral of -2 plus I to 5 plus I z cube dz is equal to first line integration AB. Integral of AB z cube dz plus integral of line BC z cube dz is equal to the line integral AB is a real axis. X varies from -2 to 5. -2 to 5. So substituting z cube. What in the first equation should be x plus I whole cube we get into dx plus the line BC integrated along the y-axis 1 to 3. 1 to 3. Again I am substituting 3 plus I y whole cube and items. So this is a real axis plus this is imaginary axis. I am substituting. So here simplifying z cube x plus I y whole cube, simplifying we get this term. So again we integrating with respect to x here, integrating with respect to item here. Suppose suddenly we can take I outside here, items of integral from 1 to 3, 3 plus I y whole cube dy. So integrating x plus I whole raised to 4 divided by 4, integral from -2 to 5 plus 3 plus I whole raised to 4 divided by 4, integral from 1 to 3. Suddenly we are simplifying, replace x by 5 minus replace x by 2 we get here. Again replace here y by 3 and minus y by 1. So simplifying we get 1 by 4 times of 131 plus items of 408 we get it. Now we come to the one more example. This, see, if we come to the in the line integrations along this in the form of C1, C2, C3, direction is very important. Suppose this is evaluate integral of C mod z square dz, where C is a square with vertices 0, 0, 1, 0, 1, 1, 0, 1. See, first make a graph. Take a graph. So along the x-axis, so first using vertices, plot a graph. Using the vertices, plot a graph. So 0, 0 and 1, 0 and 1, 1 and 0, 1. So this is make a graph. So that is. So again 0, 0, 0, to 1, 0 I call the C1 curve. Again 1, 0 to 1, 1 I take a curve C2. Again 1, 1 to 0, 1 I call C3. Again we come to 0, 1 to 0, C4. So see, observe here in the curve, it's a square curve. Line OA is a C1, line AB is a C2, line BD is a curve C3, then DO is a curve C4. See, observe here. So integral of along a C you are split into 4 parts. Integral of C1 mod z square dz plus integral of C2 mod z square dz plus integral of C3 mod z square dz plus integral of C4 mod z square dz. I call this equation 1. Now again mod z square I am simplifying, substituting this. So absolute values of z square, suddenly we get real parts. Absolute values of z square, suddenly we get real part. X square plus y square. Again dz should be dx plus I dy. Dx plus I dy. Now I come to the second problem. I am applying the along a line OL. Along a line OL. Curve C1. Where along a line x-axis y should be 0. Along a line x-axis y should be 0. Suddenly y equal to 0. Dy is 0. So substitute mod z square dz. So y is 0, suddenly dx we get. Dx. Y is 0, dy is 0. So suddenly a substitute. If we come to the along a line AB, curve C2, where so you're moving x from 0 to 1, x is 1. So x is 1, dx is 0. So again I come to problem mod z square dz. So x is 1 square plus y square. So dx is 0. So I dy we get. So 1 plus y square I dy. Again along a curve BD. So we have y is 1. So y is 1. So more distance, y is more. So dy is 0. Mod z square dz should be x square. Y is 1. X square plus 1. So dy is 0. We get dx. So x square plus 1 dx we get. So along a curve DO. So curve C4 we have x is 0 because this is imaginary axis, y is, so x term is 0. X is 0, dx is 0. Substituting in the form x is 0 we get y square, dx is 0. So y square I dy. We get y square I dy. So see, if you come to the problem, integral of C mod z square dz should be equal to integral of C1 mod z dz plus integral of C2 mod z square dz plus integral of C3 mod z square dz plus integral of C4 mod z square dz. I am substituting. In the line C1, x varies from 0 to 1. So x varies from 0 to 1. Substituting along a line C1 should be x square dx plus. So along a line C2, this is imaginary axis, plus items of integral y from 0 to 1. See, observe here, y varies from z. So 0 to 1, y varies from 0 to 1. So I 1 plus y square we get, I dy. Plus along a curve BD, so here x varies. So x varies from 1 to 0. X varies from 1 to 0. Yeah, we resulted we get x square plus 1 dx. Plus along a curve DO, so where items of y varies from integral y varies from 1 to 0. So y square dy. So direction is very important. Make a direction curve 0 to A to B, B to D, D to O. This direction is. If you change the direction, the integration should be reverse. Keep it in mind. If you change the direction, integration is reverse. So starting to integrate, integral of x square we get x cube by 3, integral from 0 to 1 plus I times of integrating y, 1 integration y, so y cube by 3. So we get this x cube by 3 plus x integral from 1 to 0 plus I times of y cube by 3 integral from 1 to 0. Again we have simplified. Totally we get 1 by 3 plus I times of 4 by 3 minus 4 by 3 minus I by 3. We get this is the term minus 1 plus I. Again this is the resulted in complex form. So therefore integral of mod z square dz is equal to minus 1 plus I along a given path. So if we come to the one more example, so evaluate integral of 0 to 2 plus I mod conjugate of z whole square dz. Conjugate of z square dz along a line x equal to 2 1. So only real axis. Simple problems. See, first given sources mod conjugate of z square. So what is the conjugate? Simplify x minus iy whole square. Conjugate. If z is equal to x plus iy, what is conjugate? Should be z x conjugate of z equal to x minus iy. See whole square. So it should be x square minus y square minus I times of 2y we get. If it's 2xy, we simplify here, we get x square minus y square minus I times of 2xy. And derivative dz should be equal to dx plus I dy. Now, see also is given x along a line x equal to 2y. Along a line x equal to y. Differentiate dx equal to 2 dy. So also z varies from 0 to 2 plus I. So that is z varies from 0 to 2 plus I. That is, if x varies from 0 comma 0 to 2 comma 1. So 2 comma 1. So x varies from 0 comma 0 to 2 comma 1. So suddenly 0 less than or equal to y less than or equal to 1. Yeah. So if we come to the problem, I am substituting the values. Therefore, here first integral of this is the along I totally convert x in terms of y because I am substituting x equal to 2y. Converting x in terms of y varies from 0 to 1. So I am substituting what is x square, we get 4y square minus y square minus I times of 4y square. Now, what's a dz become 2dy plus I dy. Now, again, I am simplifying here 4y square minus y square. Again, I will get 3 minus 4i of y square 2 plus I dy. Now, simplifying. So, again, we get simplifying here. If we constant term, if we take outside, what's a constant term? I'm taking 2 plus I is constant. I'm taking outside. Again, is simplifying here. We get 5 times of 2 minus I. We get integral of 0 to 1 y square we left. Again 2 minus I. For integral of y square we get y cube by 3. Run from 0 to 1. Totally we get 5 by 3 2 minus I. This is the form and result. If we come to the one more examples. If you come to the in form of a Euler formula form. This is problem Euler formula form. See in suppose in polar form. See, evaluating integral of C conjugate of z whole square dz conjugate of dz whole z, the circle mod z equal to 1 and mod z minus 1 is equal to 1. See, observe the problem. Mod z equal to 1 and the second one mod z minus 1 is equal to 1. See, if you come to the problem, first statement, mod z is equal to 1, this is the meaning. It's a circle whose center is 0 comma 1 and the radius equal to 1. This is the meaning. Mod z equal to 1 is the center whose center is 0 is a circle. Mod z is equal to 1 is a circle whose center 0 comma 0 and the radius is 1. See here. Mod z equal to 1 is a circle with the center 0 comma 0 and the radius equal to 1. On this circle we have z equal to r e power I theta. So here r radius is 1 e power I theta. So simply say z equal to e power I theta. So what's the derivative there? Dz should be equal to I e power I theta d theta. So dz should be equal to I e power I theta d theta. Now theta varies from, this is around a circle, theta varies suddenly theta varies from 0 to 2 pi circle. So 0 theta varies. So all you are simplifying. What is the theta varies from z? Then you know the given z and dz. Now come to the problem. Also, conjugate of z whole square should be equal to, I am substituting all values. Z is given, conjugate of z we get e power minus 2 I theta. So e power minus 2 I theta. Now I come to the problem. Therefore, integral of c conjugate of z whole square dz should be equal to, what's the theta varies from? 0 to 2 pi. What's the conjugate of z square? It become e power minus 2 I theta. What's the dz is? I e power I theta d theta. So I is constant, I take outside. E power minus 2 theta, e power I theta. Simply we get e power minus I theta d theta. Again, so I started integrating with respect to theta. You get e power minus I theta divided by minus I. Again we get I get cancelled minus I. If you replace to theta by 2 pi, suddenly we get minus sign of e power minus 2 pi I minus 1. E power 0 is 1. So e power minus 2 I minus 1. So again I take minus of minus, you get plus 1 minus of e power 2 pi I come to the cos theta plus I sin theta form. Cos theta plus I. Here theta is 2 pi. You get cos 2 pi minus I 2 sin pi. Cos 2 pi minus I sin 2 pi. Cos 2 pi is 1. Minus I 2 pi is 0. So 1 minus 1 suddenly become 0. Now we come to the second problem. Mod z minus 1 is equal to 1. Again here, this is a equation of a circle whose center is 1 comma 0 and radius is 1. This is mod z minus 1 equal to, this is the form with center equation of circle whose center is 1 comma 0 and radius 1. On the circle we have mod z minus 1. Again I am simplifying. So mod z we convert is r e power I theta. I take on this side e power I theta. So r is 1. So suddenly z equal to 1 plus e power I theta. What's dz become? I e power I theta d theta. Again I substituting conjugate of z should be equal to 1 plus e power minus I theta. Therefore is simple mod z conjugate of z square we get square this number we get 1 plus 2 e power minus I theta plus e power minus I theta. So now come to the problem. Therefore integral of c conjugate of z square dz become, so simplify, integral from 0 to 2 pi 1 plus 2 e power minus I theta plus e power minus 2 times I theta d theta. Now totally I am starting to integrating. So integrating well we get 1 I e power I theta. I am multiplying. So plus I e power I theta we get plus 2I e power minus I theta e power I theta we get cancel e power 1 we get 1 we get plus I e power minus I theta d theta. So starting to integrating we get e power I theta plus 2I times of theta minus e power I theta integral from 0 to 2 pi. So simplifying we get this is again here first make it as this term should be equal to e power 2 pi. Again we get 1 here. 1 plus 0 minus 1. So again we are converting form of a Euler formula, complex nth derivative formula. So we get cos 2 pi plus I sin 2 pi cos 2 pi plus I sin 2 pi plus 4 pi I minus cos 2 pi minus I sin 2 pi. So totally we get cancelled cos 2 pi plus cos 2 pi minus cos 2 pi get cancelled. Also minus of minus we get plus I times of this term we get cancelled. We get 4I left. Again one more problems we come to that. One more problems. So integral of run from 0 comma 3 to 2 comma 4 2y plus x square dx plus 3x minus y dy along a parabolas. We know the parabola form. So parabola x equal to 2t, y is equal to t square plus 3, one form. Again in the second form, the straight line from 0 comma 3 to 2 comma 4. 0 comma 3 to 2 comma 4. See if you come to the problem 1, so integral of 0 comma 3 to 2 comma 4 2y plus x square dx plus 3x minus y dy. Now see in the first problem x varies from 0 to 2. 0 to 2 means that is x equal to 0 2t equal to 0 means t equal to 0. X equal to 2 2t should be equal to 2 or t equal to 1. Now you come to this is simply I say t is a parameter. Simply say I convert x in terms of t. X. See if x equals 0, what is x is given? X is 2t. So x is 2t equal to 0. Suddenly t equals 0. X equal to 2t. So we can replace x replace t by, so 2t is equal to 2. So t equal to 1. So t varies from 0 to 1. Now I come to the problem. Integral from 0 to 3 2 comma 4. So I am substituting here 2y plus x square dx plus 3x minus y dy. Now replace t varies from. So convert it all x term in terms of t. T varies from 0 to 1 2 times of what is y? So simplify t square. So simplify here t square plus 3. Y is t square plus 3 plus x, replace x by 2t, also we get 4t square. Again dx become 2 dt. Again plus 3 times of 2t minus t square plus 3. Again what's dy become 2 dt. Because you are differentiating here, 2 dy should be equal to 2t dt. Yes. Again simplifying here. So integral run from 0 to 1 2 times of 6t square plus 6 plus 6t minus t square minus 3 times of 2t dt. So again integral from t varies from 0 to 1 24t square minus 2 cube t cube minus 6t plus 12 dt. So again simplifying we get integrating with respect to t, we get 24 t cube by 3 minus 2 t raised to 4 by 4 minus 6 t square by 2 plus 12 times of t we get. So simplifying, we get 8 minus 1 by 2 minus 3 plus 12. So suddenly we get 33 by 2. We come to last in the form same in the equation in the straight line form 0 comma 3 to 2 comma 4. So again I make a line equation, straight line equation. Y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So again in line form I substituting here x1 y1 x2 y2. Here y1 is 3 and x1 is 0, y1 is 3, x2 is 2, y2 is 4. So suddenly here x1 is 0, y1 is 3, x2 is 2, y2 is 4. So simplify, y minus 3 divided by x minus 0 is equal to 4 minus 3 divided by 2 minus 0. Suddenly we simplify, x is equal to 2y minus 6. Hence dx should be equal to 2 times of dy. So again replace y varies from 0 to 4. Replace y varies from 0 to 4. So y varies from 3 to 4. Y varies from 3 to 4. So replace all x in terms of y. We get 2y plus 2y minus 6 whole square 2 times of dy. Dx will plus 2 times of dy. Again plus 3. 2y minus 6 minus y times of dy. Or totally we simplify. We get y varies from 3 to 4. Y varies from 3 to 4. 4y square minus 22y plus 36 times of 2 plus 5y minus 18 times of dy. Totally we first we open this bracket and simplify. We get 8y square minus 39y plus 54. So starting to integrate with respect to y, we get 8 times of y cube by 3 minus 39 times of y square by 2 plus 54 times of y. So replace y by 4 minus 3. So we get this is data. So we get 296 by 3 minus 273 by 2 plus 54. We get 97 by 6. This is the